Welcome to section 11.5, the area of regular polygons. We're going to find the area of regular polygons. For homework, we're going to work on page 533, numbers 2 to 22, the evens. Now, first thing we're going to do is talk about what a regular polygon is, and hopefully we already know this. A regular polygon is a polygon that has all equal sides and all equal angles. Now, in order for us to find the area of the regular polygon, I have a real short clip for us to watch.
The first thing we need to do is to write it inscribed in a circle. And by doing that, we've created the ability to draw an apothem. Now, an apothem is a perpendicular segment from the center of the circumscribed circle to one of the sides of your polygon. Now, the reason why this is important is because if we want to calculate this hexagon, so again, this will apply to any regular polygon, what we're going to do is we're going to think, well, Mr. McCall, I have no idea how to calculate that area. But what I do know how to calculate is the area of a triangle. So if I divide this hexagon into congruent triangles, and they'll all be congruent because it's regular, then all I have to do is add up the area of my 6 triangles. So you could say the area of the hexagon is equal to 6 times the area of one of those triangles. But how do we calculate the area of one of those triangles? Well, if you recall, in order to calculate the area of a triangle, you need 2 things. You need the base and its corresponding height. So that's why we need the apothem, is the apothem is that corresponding height. So specifically for a polygon, we're going to call this A, and we're going to call that base S, where if we go back here, S is our side length. So notice that the sides will all be the same for a regular polygon. So the area of this triangle is going to be the apothem, which is the height, so I'm going to say 6 times the apothem, times the base, which is S, divided by 2. So the area of a hexagon is equal to 6 times the area of one of your triangles. But that's not very useful because this is only going to apply to a hexagon. So let's make this area formula for any type of polygon. So instead of writing 6, I'm going to write n for the number of sides. So I can write this as apothem times side length times the number of sides, all divided by 2. Now if we look at this, I see that I can simplify this a little bit more. Getting back to our regular polygon, the perimeter, capital P, of this polygon is going to be 1, 2, 3, 4, 5, 6s. If I had a pentagon, that would be 5s. So what I'm going to do is I'm going to say that the perimeter of any regular polygon is n times s. So I can substitute in for n times s, capital P, which is going to stand for perimeter. So there's going to be 2 ways to write your area formula. And I'm going to erase this to make it a little bit clearer here. So we're going to say the area of any regular polygon is equal to apothem times side length times the number of sides divided by 2. Or if we substitute in for n times s, it's going to be the apothem times the perimeter divided by 2. So you have 2 different formulas, both of which will calculate the area of any regular polygon.
So, hopefully that video was okay and pretty easy to understand. Whenever we want to calculate the area of a regular polygon, the formula that we're going to want to use is going to be 1/2 the perimeter of the regular polygon times the apothem. The apothem being the segment that starts at the center of our regular polygon and is perpendicular to one of our side lengths. So here we go. We're going to start off by finding the area of this regular hexagon. So here we go. We know it's a regular hexagon. 6 sides, all of which have side length 6 units. The area of any regular polygon is going to be 1/2 the perimeter of that polygon times the apothem. The apothem again being the perpendicular segment. Now, here we go. We know that that perpendicular segment is actually going to be the height of that triangle being formed. The sides of those triangles are actually radii of a circle that circumscribes about this polygon. So we know then that we have an isosceles triangle. We have the altitude of an isosceles triangle is going to also bisect that. So we have sides 3 and 3. Now, next thing that we know is in a regular polygon, we know all my angles is going to be 120 degrees. The way I found that is the number of sides minus 2 times 180. So 6 minus 2 times 180 was 720 degrees divided amongst 6 equal angles. So each angle was 120. Now if my full angle was 120 degrees, that radius bisects my angle, forming a 60 degree angle. So I have a 30, 60, 90 triangle. I need my apothem, that height. If across from my 30 is 3, across from my 60 is going to be 3 square root 3. So here we go, plugging it in. 1/2 the perimeter. We have 6 sides of 6, giving me 36, times my apothem, 3 root 3. Half of 36 is going to end up giving me 18. 18 times 3 root 3 is 54 root 3 square units. Okay, now you try one. We're going to find the area of this regular hexagon with a radius 18. Press pause and let's see what you can do. So here we go. Again, the pieces I'm going to need is going to be the perimeter and the apothem. And the first thing that I'm going to do is I'm going to draw in my apothem. Now, we remember from our last example. In a hexagon, I have 120 degree angles, and that radius splits it into 60 degree angles. So we have a 30, 60, 90. We need that apothem, and we also need that side length. Now, we know what's across from my 90 is 18. Across from my 90 is 18, across from my 30 is 9. And if that half is 9, so is this. So each side is going to be a total of 18. If across from my 30 is 9, across from my 60 is going to be 9 square root 3. So here we go. Our formula. 1/2 the perimeter times the apothem. My perimeter is 6 sides of 18. 6 sides of 18 is going to give me 108. Times my apothem, 9 root 3. Half of 108 is 54. And 54 times 9 root 3 is 486. Square root of 3 square units. Here's our next one. It's the area of a regular triangle. We have 2 ways that we can do this. Why don't you press pause and see what you can do. So here we go. If it's a regular triangle, I know it's equilateral and equiangular, which means all my angles here are going to be 60 degrees. Now, using my area of a regular polygon formula, I want to find my apothem. And I'm going to draw in my radius as well, which is going to split that 60 degree angle into 2 30s. We have a 30, 60, 90. Now, that's also going to split this side into 7.5 and 7.5. If across from my 60 is 7.5, we have to divide that by the square root of 3 in order to get my 30 side. So let's clean that up. Multiply root 3 to top and bottom. That's 7.5 root 3 over the square root of 9. The square root of 9 is a 3. 7.5 divided by 3 is 2.5 root 3, which is going to be my apothem. So here we go. 1/2 the perimeter, my perimeter is going to be 45, times my apothem, 2.5 root 3, which is going to give me 56.25. Square root of 3 square units. Now, was there another option? Absolutely. Let's go ahead and let's look at that. Now, again, what I knew here is that I had a triangle that was equilateral and equiangular, so I had 60 degree angles. Now, we also know the formula for the area of a triangle. It's 1/2 base times height. We know my base is 15. We know it's going to split that base into 7.5 and 7.5. Now, what we have here is a 30, 60, 90. If across from my 30 is 7.5, across from my 60 is 7.5 square root 3. So here we go. 1/2 of 15 times 7.5 root 3. 1/2 base times height also gives me 56.25 square root 3 square units. So we have two ways of finding the exact same thing. So here's another one. We're going to find the area of the regular quadrilateral. Again, you can use the area of a regular polygon formula, especially if you want to practice it. Or if you want, there's an alternate method you could use as well. Let's see what you can do. Press pause. So here we go. In a regular quadrilateral, all equal sides and all equal angles. In this case, a quadrilateral has 360 degrees divided amongst 4 angles gives me 90-degree angles. That radius that's drawn is going to split into two 45 degrees. So when I drop down my apothem, I have a 45, 45, 90. I need my sides, and I'm also going to need my apothem. To get from my 90 side back to my 45 side, I'm going to want to divide by the square root of 2. And we clean that up. Multiply root 2 to top and bottom. That gives me 8 root 2 over the square root of 4, which is 2. Clean that up and reduce. My 45 sides are 4 root 2. And if it's 4 root 2 on this half, 4 root 2 on that half, which means all my sides are 8 root 2. 1/2 the perimeter, 4 sides of 8 root 2, which is 32 root 2, times my apothem, 4 root 2. Half of 32 is going to give me 16 root 2 times 4 root 2, which is going to end up giving me 64 square root 4, which gives me 128 square units. Now there was another method to doing this. Another way we could have done this is what we could have done is drawn the second half of this diagonal. My full diagonal right here is going to be 16. And again, we have a 45, 45, 90 triangle because it's built out of a square, which would be our regular quadrilateral. Across from my 90 is 16, across from my 45. Let's go ahead and divide that by root 2 and clean it up. Top and bottom. 16 root 2 over root 4, which is 2, and reduce. My sides are 8 root 2. We know the area of a square can be sides squared or base times height, which is 64 root 4, which is 128 square units. Different method, same end result. So our next example is going to be a little bit different. We're going to find the area of the regular pentagon. Now, we don't have any nice formulas except the area of our regular polygon, which is 1/2 the perimeter times the apothem. When we can find our perimeter, we have 5 sides of 8. 5 sides of 8 give me a perimeter of 40, but I need to find my apothem, so let's draw it in. It's perpendicular and bisects that base. And now let's draw in our radius, making our right triangle. Now, we have to find the measure of that angle. To find that, number of sides minus 2 times 180 gives me 540, divided by 5 sides, which is 108 degrees for the full angle. That radius bisects that angle, so each angle is going to be 54 degrees. Now, we don't have anything nice, so how are we going to find out what that length of that apothem is? If you said trig, you're exactly right. Let's label our sides. Our hypotenuse is across from our right angle. Across from our reference angle, 54 is our opposite side, and attached to our reference angle is our 4, our adjacent side. Don't care about that hypotenuse. We're using O and A, which was our tangent function, came from that TOA. The tangent of our reference angle, 54, equals our opposite side over our adjacent side. X is on top, so we're going to multiply both sides by 4. And here we go. We're going to type in tangent of 54 times 4, which lets me know that each side is going to be 5.5. 5.5 is the length of that apothem. The apothem, again, is the perpendicular segment from the center to the middle of our side. Let's plug that in. Half of 40 is 20. 20 times 5.5 gives me 110 square units. And we're set. Alright, so here we go. We have an example for you to try on your own, very similar to our last one. You're going to find the area of the regular octagon. Give an apothem 9 inches. Press pause and let's see what you can do. So here we go. We have 1/2 the perimeter, which is unknown, times our apothem, which is 9. Now, the first thing that we're going to want to do here is draw in our radius. And we have to find out what the measure of this angle is. So here we go. Number of sides minus 2 times 180 gives me 1080 divided about 8 angles, which is going to give me 135 degrees per angle. Split that in half because of the radius and we get 67.5 degrees. We have to use trig. Label your sides. Hypotenuse, opposite, and adjacent. We need to find out what that adjacent side is because that's going to help me find my perimeter. We're going to use tangent again. Tangent is 67.5 equals 9 over x. X is on the bottom, which means we need to switch it around. We get 9 divided by the tangent of 67.5, and let's type that in. That's going to end up giving me 3.7. If this is 3.7, that makes this 3.7, which means all my sides are going to be 7.4. Now, for my perimeter, I'm going to have 8 sides of approximately 7.4. For that perimeter, we're going to end up with 59.2. So here we go. 1/2 times 59.2 times 9 is going to end up giving me a total area that's equal to 266.4 square units. So here's our last example. We're going to find the area of the shaded region. So what we're looking to do is find the area of the regular polygon and take out the rectangle in the middle. Let's press pause and see what you can do. So here we go. The area of the regular polygon is 1/2 the perimeter, 6 sides of 8, which is 48. I need to find that apothem. So here we go. The apothem. I'm drawing in purposely here so you can see what I'm going to do with this. It starts at the center and hits the middle of one of my sides. If that full side right here was 8, it means it's split it into 4 and 4. Now I have to draw in my radius. A hexagon has 120 degree angles. That radius splits it into 60 and 60. So here we go. We have a 30, 60, 90 triangle. Across from my 30 is 4. Across from my 60 is going to be 4 square root 3. That's going to be my apothem. Half of 48 is 24. 24 times 4 root 3 is going to give me 96 square root 3 for the area of my regular polygon. Now, the area of my rectangle. Area of my rectangle is base times height. My base is going to be 4. For my height is the distance between the bases. Well, that's actually just going to form 2 apothems for me. 4 root 3 and 4 root 3. So the height is going to give me 8 root 3. 4 times 8 root 3 is 32 root 3. So to find the area of my shaded region, I'm taking the area of that regular polygon minus the area of that rectangle, which is going to give me 64 square root 2 square units. So here's the answers to our homework. I know it was kind of a lot to take in, but if you think of any questions, please let me know tomorrow. And as always, have a good one.